The exercise rate of the reaction, the doubts, the last I discussed, that was page 13. And then we have page 15. So in this question, why the reaction mixture is in the second experiment contain? It's a similar question, as you can see, like a hydrochloric acid and there's a zinc foil, and one of the reactions there was only zinc foil, and the second reaction it was held by a copper. So copper is actually acting like a catalyst for this reaction. So question is, why the reaction mixture in the second experiment contain copper, and include an equation um, in your explanation. So basically, why there is a copper there? Copper is acting like a catalyst. Like from the graph, you can identify it's alter the rate of the reaction between a metal and zinc acid was investigated. A piece of zinc foil was added. The hydrogen gas was evolved and collected, as you can see. Then experiment 2 was repeated. Yeah, but this is experiment 2 was repeated, shows that zinc metal and hydrochloric acid is catalyzed by copper. Then what happened? A small amount of aqueous copper chloride, means we have copper chloride. What will be the formula of the copper chloride? Copper, the Roman number 2 is there, so it's a valency of a copper. So copper is +2. And chlorine belongs to group 7, so it's -1. So copper to chloride will be CuCl2. Was added to acid before a zinc. So copper chloride does not react, but then we add a zinc. So when we add a zinc, what will happen? The basic idea is that, like, first we were having acid. Copper does not react with acid. So first we were having an acid. In this acid, we add a small amount of copper chloride. So CuCl2 is there, but there will be no reaction between them. Yeah, that is what happens. Zinc displaces the copper. When we add zinc metal, two things will happen. Zinc can react with an acid. Zinc can react with copper chloride as well, because zinc is more reactive than copper. So zinc can displace copper. So zinc can displace copper. As a result, it will produce zinc chloride plus a copper. And when this copper metal is formed, this copper metal will catalyze the reaction between zinc and acid. So this is what the reaction chemistry is. Like we were having a mixture of acid and copper chloride. So in a conical flask, we have a mixture of, there is an acid here and there is copper chloride, a salt. But there is no reaction between acid and copper chloride. So there is no reaction between acid and copper chloride. But then what happened? We add zinc metal. When we add zinc metal, zinc can react with both copper chloride and it can react with acid. So when zinc react with copper chloride, the equation will be zinc plus copper chloride. It will produce zinc chloride plus copper. So there will be a formation of a small amount of copper in the base. And this copper will catalyze the reaction between zinc and acid. Like zinc plus acid give salt, zinc chloride plus hydrogen will be there. But this reaction will be catalyzed by the copper. So explain why the reaction mixture in the second experiment contain a copper metal. So what is and reason for that? The reason is zinc is more reactive than copper. So it displays the copper from copper chloride or copper 2 chloride. And what is the equation for that? The equation, this equation is there, that zinc plus copper chloride will give zinc chloride plus copper. Is it clear? That how a mixture contain a copper metal even though it was not added. Copper chloride was added, but a mixture contained copper metal because zinc displaces the copper from the mixture. And that copper which is produced is acting like a catalyst for another reaction between zinc and acid. Yeah, it is right that the copper is catalyzing a reaction between zinc and acid. That is true. But the question is not about the question is why the reaction mixture contain copper. That is the question. Why there is a copper? So what is the reason for having the copper is because the copper is displaced by the zinc. As a result, a copper metal is formed. So from the copper is displaced from copper chloride, like zinc displaces the copper and it forms zinc chloride and copper metal. That's why in the mixture there is a copper metal. The question is not what is the role of a copper. The question is why there is a copper in the second mixture. If the question was like what is the role of the copper in the mixture, then you will mention it is acting like a catalyst to speed up the reaction. But the question is mainly why the mixture contain copper. So that is when a copper is displaced from by the zinc, as a result, a copper metal is formed. That's why there is a copper metal present here. Is it clear, this one?
Yes, sir, clear.
Okay. The next part, how the graph 2 shows that the copper catalyzed the reaction, it's of 3 marks. So even though the answer is very like short answer you can write, but how to score 3 mark when you check the graph. First thing, when a substance catalyzes the reaction, it should alter the rate. So how it alter the rate? When you check the graph, it is steeper. So the graph 2 with the copper is much steeper, means the rate is faster. And one thing you have to mention, the final amount does not change. Final amount of a product is same. If the final amount is different, then the substance cannot be a catalyst because catalysts cannot alter the amount of the product. They can only alter the rate of the reaction. So 3 points you will include: steeper slope, shows faster rate, and the final product or amount of a gas does not change. If the first experiment was repeated using ethanoic acid is a weak acid instead of hydrochloric acid, how and why would the graph be differ from graph 1? So if we compare, if it's a weak acid, how these graphs will be different? You have to use, so it will be less steeper. But the thing is, you don't have, because the question is how they're different. If you say the final product is same, it means you're writing a similarity. So how the two graphs will be different? If we use ethanoic acid, what will the graph of ethanoic acid? It will be like this. Then what are the points you will mention? You will mention it will be less steeper. That is one. Why it is less steeper? Because it is a weak acid. Then if it's a weak acid, then yeah, less steeper, slower rate. Why? Because it's a weak acid. Weak acid contain less, like few ions are there or ionized partially. So if it ionized partially, it contains few ions or few particles to react. Few particles means they will have less collisions, less effective collision or successful collision. So that's why the rate will be, yeah, fewer collisions are there, less collision. That's why the rate will be slower. So how you score 4 mark? 1 mark you mentioned lower gradient or less steeper. Second mark, you mentioned the rate of the reaction, the ethanoic acid is a weak acid. That is the second mark. Then you will mention it contains few particles. That is the third mark. When you mention like less collagens are there, you score the fourth mark. Yeah, the part of an acid which does not ionize, that's true, that won't react initially. But what will happen is, how the final product will be same. If I'm using the same amount of a hydrochloric acid, say we have two acids, yeah, that is the right explanation, that if we have a weak acid, other particles will collide, but they don't react. Like for example, say I will explain an idea. You have a hydrochloric acid. Say you have 3 molecules of hydrochloric acid. So it contains H, because it's a strong acid, it ionizes completely. Like all of them, almost all of them will dissociate or break down into ion. For a weak acid, what happened? Say ethanoic acid, this is a formula for ethanoic acid, CH3COOH, which contains CH3CO and H plus. If we have 3 molecules, one is example an ion and 2 of them remain as a molecule. The molecule does not react. So first, when we add, like example, we add a piece of magnesium or any other metal, this magnesium will react with, like magnesium react with all the ions and instantly it will react. But for ethanoic acid, what will happen? First, one of the magnesium react with hydrogen ion, then another molecule break down and react with hydrogen ion, and then another molecule break down and react. So it will take longer time for this process. First, the molecule break down, because in the beginning, there are very few ions. When we add a magnesium, first it causes a magnesium, cause these ions to separate and then it reacts. So it will take longer time, but the final product will be same if we have the equal amount of both acids. Is it clear, this one? That why weak acid reacts slower compared to strong acids?
Yes, sir. Clear.
So in the beginning, the reaction will be very slow, then the molecule break. So that is causing an ionization in the weak acid. But in strong acids, already ions are there, so instantly they will react. But for weak acid, the molecule first break into ion and then to react, so it takes longer time. So this was page 15. Then we have page 17, part B. Yes, page 17. The experiment was repeated. 2 pieces of magnesium ribbon were added to 100 cm cube. One sketch on the graph, the same grid. So first, there was only, like in this reaction, the magnesium, the rate of a reaction depends on the temperature, catalyst or light. A hydrochloric acid, a piece of magnesium was added. Only one piece was added. So it was giving how much, if you basically you double the amount, like how many boxes are formed for the gas? 1, 2, 3, 4, 5, and 6. Then if I double the amount, 7, 8, 9, 10, 11, 12. So the reaction will be faster, steeper, and the final product will be double as well. So this is how I should complete. Like if I'm using 2 pieces of magnesium, 1 piece of magnesium was like giving, say, 6 boxes of volume of hydrogen on the y-axis. So 2 pieces will give double. If 3 pieces, 18, 4 pieces, 24. So it should be double volume and steeper. The experiment was repeated using 1 piece of a magnesium ribbon using ethanoic acid. Again, you can see it's a weak acid. Describe how the shape of the graph would differ from the one on the grid. So less steeper, few collagen, few particles, contain less ions. So final product will be same, but the reaction will take much longer time to complete. So weak acid reacts slower than strong acids. The first marking point, because with reference to the graph, you have to say, so first marking point is less steeper, like, because they say state and explain, describe the shape, differ from the one. So how the shape would be differ? Number one, it will be less steeper. Number two, it will take longer time. So this is how the marks are distributed. Lower gradient, longer time for the reaction to complete. Or smaller gradient and longer time, like takes more time. The reaction rate increases when the concentration and the temperature increase. Use an idea why the increasing a concentration increase the rate. So increasing a concentration means more particles, more collagen, more successful collagen, and increasing a temperature increases the kinetic energy. So increasing concentration increase the amount, yeah, which increases the more successful collagens are there, thus the rate increase. That's right. And for temperature, increasing a temperature increase the kinetic energy or speed. More particles collide, more number of successful collisions, greater number or greater proportion of the particle have energy more than activation. Don't forget this sentence, that greater proportion of the particle have energy more than activation. Next, this was page 17, then 19. An alternate method of measuring a rate of a reaction would be to measure the volume of a carbon dioxide at a regular interval. Sketch this graph. So how we'll sketch a graph? Because in the beginning, like carbon dioxide is a product here. So in the beginning, the reaction will be faster, then it slow down and eventually it will stop. Whenever a question is sketched, you don't have to mark any points, like label any points on it. You don't have to mention, label the axis. Just the points, just the sketch, you have to like how the graph will appear. So page 19, then we have page 20. Twenty grams of a magnesium, 20 grams of a magnesium, calcium carbonate, 20 grams of small lumps of calcium carbonate, 40 cm cube of hydrochloric acid. The mass of a content in the flask was measured. The mass of a carbon dioxide with gas given off is measured. How much? Like we just take a difference, compare the mass difference and know how much carbon dioxide gas is given off. How could you determine the mass of a carbon dioxide given off? So how will know like how much carbon dioxide, what mass of carbon dioxide given off? So we'll measure the mass in the beginning and we'll measure the mass after a certain time interval. Like in the beginning, say total mass of a content in the flask is 30 gram. And after 1 minute, the mass and the content of the flask is 25. So how we'll know how much carbon dioxide is gas is given off? So we just take a difference. Take the difference of the two masses to know how much carbon dioxide gas is given off. If there were two gaseous product, we would, in this case, it's fine. Normally, like here also what happened, it's whenever a calcium carbonate is reacting, like you have CaCO3, it is reacting with hydrochloric acid. As a result, it will produce calcium chloride plus carbon dioxide plus water. So carbon dioxide gas is given off. So either you can allow this gas to escape and measure the mass of a content in the flask. So either you can measure the mass of a content in the flask with reference to time. So it will start with a maximum value and then it decreases and eventually it will be horizontal line. But it won't touch the x-axis because there is always some content left in the flask. So it won't be on the x-axis. This is one way. And you can measure the rate by taking the gradient. Or you take a difference in the masses to know how much or what mass of a carbon dioxide gas is given off. So by taking a mass difference, you for every time interval, you got how much mass difference happened. And when you sketch a graph, it means join the points, this will be the shape of the graph. So how we can measure what mass of a carbon dioxide gas is given off? So we'll measure the initial mass. We'll measure the starting mass and then the mass after like certain time interval. And then we will take a difference to know how much or what mass of a carbon dioxide gas is given off. Label the graph if where the reaction is fast, slow, where it slow down, and zero, where it like the reaction stop. So use screen annotation where I should write F, S, and 0 or on the graph, like mark point. So you have to mark a point and then write F. Don't draw the line. Don't draw the line. Just mark on the point. Mark the point. So this will be 0. Here you can mention anywhere in this region S, and in the beginning it is fast. So it is fast, slow, and reaction stop. The calcium carbonate is in excess. Explain how the shape of a graph shows where the reaction is fast, where it is slow, and where it is 0. So you have to use a graph here like how it shows which. So you just check it is faster because much steeper slope in the beginning, the like gradient. Then slow, the gradient is decreasing, more gradient fast, like or steeper. Yeah, the rate depends on the slope you can mention. Slope is decreasing, so rate is decreasing. So gradient 0 means no reaction or the reaction has stopped. But with reference to the graph, you'll mention here in the beginning, it is much steeper. That's why it is fast. Then the slope is decreasing, so slow down. And then the slope is 0, so the reaction stop. So use the term slope or the gradient because they ask, use the graph to explain which part it is fast, which part slow, and which part it is 0. Then reaction would be faster if the experiment. Next is explain in terms of collision between the particles. The rate of a reaction would be slower if 20 gram of magnesium lumps are used. Like first we use a powder, but now we are using lump. So lumps, what will the effect of these lumps? It will have a small surface area, so less collision. So they will have a few collisions or fewer collisions. The reaction rate would be faster if experiment was carried out at a high temperature. So high temperature, yep. Yeah, that's right. Small surface area, large particle size, slow down the reaction or reaction will be slower. And what about the effect of high temperature? If you increase the temperature, particles will have more energy, more kinetic energy, move faster, more collision, greater number of the particle. Don't forget to include the term greater number of the particles have energy more than activation. So the reaction will be faster. You have more particles with energy more than activation. That's a very important term whenever you refer how the temperature affects the rate or the speed of the reaction. So this was page 21 and then move to 22. In this question, the speed of a chemical reaction depends on number of the factors, including temperature and presence of catalyst. The reactions speed of reaction increases, the temperature increases. Why the speed increases the temperature? The same answer what we have discussed in the previous. The reaction involve enzymes. What are enzymes? Enzymes are biological catalysts. Enzyme can be denatured if the temperature changes. Enzyme can denature if the pH of the solution changes. You have studied in bio, I guess. There's a biological catalyst, and their activity is not like normal inorganic catalyst which we are using. They can be a catalyst at any temperature, but not the biological. Yeah, their activity depends on temp. So you can see at a certain temperature it was in speed up and then it denature. So it suggests an explanation why initial reaction speed increases at a certain temperature and then decrease. So when we are increasing a temperature, speed was increasing. What is the reason for that? Reason is there were more collagen. Yeah, they work at a specific temperature. So the answer here you will mention enzymes are biological catalysts. So it denature if the temperature change, or it destroyed also, you can, but not say killed. It's not the right term. So reaction is increases with the temperature, the particle move faster. Yeah, they denature at a temperature, at high temperature, and if it increase, like it has an optimum temperature to work. That is also right, the active side, but best is like the answer for this one, reaction will be faster where the temperature is increasing, but after certain temperature the enzyme denature. That's why they are no longer remain as an active catalyst, or the that's it. An organic compound decomposes to give off nitrogen. The speed of reaction can be determined measuring the volume of nitrogen. Sketch. If we catalyze this reaction by a catalyst, so reaction will be faster, but the final product will be same. So it's cheaper, but with the same product. Then how does the speed of this reaction vary with time? So how, this is again the same, like it always, speed of a chemical reaction decreases with time. And why the speed of a reaction vary, like why does the speed of a reaction vary with time? As the concentration decreases, less particle, less collagen. That's why the speed of the reaction. Because in the beginning, like we were having more particles of the reactant. Here, at the beginning of experiment, like example, you will have more particles of the reactant. So they will. So in the beginning, you were having more particles of the reactant, but the number of the particle decreases, so less collagen, and eventually, why stop that? This is, you cannot say limiting reagent because this have only one reagent. So you'll mention the reactant used up. So no number of the reactant particle decrease. That's right. So less collagen between the particle, which reduces the rate as well. And until you're not left with either, if two reactants are there, one is limiting, another one is excess. If there's only one reactant, then you will not mention limiting reagent. You will always mention that the reactant used up. So this was exercise 2 related to rate of a reaction. Any other question or a doubt from this?